I'm recording. You have a quiz in here. On the calendar, it said it was going to be on Monday. But after some thought, me and Miss Gandhi decided tomorrow was a great day because if we waited for the whole weekend, I just don't love y'all's quiz to get grades on a Monday. This quiz that you just took was only 50 points. Tomorrow's quiz will be the other 50 points. You're going to have 4 graphs, and they're going to look like yesterday's. Only yesterday. Okay? And we'll practice a little bit when y'all come in. I'm going to have y'all do some examples. Okay? But it'll be vertical stretching and then vertical shifts up and down. Okay? Y'all can do that. I have full faith in you. Louder? You'll have 13 minutes. Because there will be 4 of them. Transformations. And it'll all be vertical shifts. It will not be what we're doing today.
No stretching?
Oh, stretching, yes. Yeah. No, not just translations. Transformations. Yeah. No. Okay. What we're doing today, y'all, what we are doing today is going to be involved this equation. Y equals f of b to the x minus c. Can everybody please highlight? And if you need a highlighter, I forgot to put them out. Can you put out my highlighters? They're on the shelf. Down. Yeah. If you need a highlighter, go get a highlighter, please. In Algebra 2 or College Algebra, you learned that our B stretches or contracts horizontally from the y-axis, and our C shifts which direction? Left or right. Alright? This is true for sine or cosine. Now, I feel like yesterday, y'all did very well when we were going over the lesson. Like, you understood it. I'm not going to sit here and say anything we do is technically easy in this class, because easy is subjective to you, right? I'm not going to say what we're doing today is hard either, but I will say that I think what we're doing today is more difficult than what we did yesterday. Again, am I saying it's super difficult or super hard? No, I just think it's more difficult. So I need you to do 2 things. 1, I need you to make sure you're paying attention. But 2, I need you to ask me questions when you're getting confused, or let me know if I'm going too fast. All right? So, this is true for sine and cosine. It will stretch or contract for the B, and then the C will go up or left or right. Now, a normal period for sine and cosine, if we look at the front pages, what is a normal period? 2 pi, right? Well, whenever we are stretching or contracting horizontally, we are no longer going to have a period of 2 pi. So to find what the new period is, we are going to use this equation right here, which is 2 pi divided by b. You are going to see me, instead of writing out new period, you're going to see me write NP, because I'm going to be a little bit lazy about it. Okay? So, you are only going to find a new period if you have a B value. Now, how can I tell an A value from a B value? Here's yesterday's A value. Here is today's B value. How can I tell the difference? There's no parentheses.
Oh, it's in this way of the F.
Yeah, so look. Right here, where is my 2? In front of cosine. Right here, where is my 2?
After cosine.
It's after cosine, in between cosine and x. So you're going to have to be careful when I start throwing this all together, identifying whether it's an A or a B. An A value is way out front, and it's multiplying by your y because your y was cosine of x. Your B value is a completely different situation, and it is in between the cosine and the x. So this B value is going to make me have to find a new period. So how do I find my new period? 2 pi divided by b. Well, what is my b value here? 2 pi divided by 2. What is 2 pi divided by 2?
Pi.
Just pi. So my new period is pi. What questions can I answer so far? Now, if you look up, do you agree on my parent function that we just did a little while ago, we quizzed over, the cosine function starts at 0, 1, and goes all the way to 2 pi 1. Do y'all agree with that? Do you also agree in the middle of this function, it goes to -1 at pi, right? It is no longer going to do that. Now, oh, we got to label this. Sorry. 1, 2, 3. 1, 2, 3. Now I only need to label to pi. Why? Because that's my new period. It's not going to go all the way to 2 pi anymore. Still label your y-axis. And where does cosine start at? It's still going to start at 0, 1. But now, where is it going to end at? Pi 1. Everybody make it end at pi 1. Well, where are all the other points? Where is it going to go down to -1 at? Why? You're right, but why? It's because it's in the middle of 0 and pi. And don't you agree, in the middle of 0 and 2 pi, it goes down here? Same thing here. In the middle of 0 and pi, it's going to go down to -1. Where is it going to hit my zeros at? In between 0 and pi over 2, what would that be right here? It would be pi over 4. And what about on the other side? What's in between pi over 2 and pi? 3 pi over 4. And now, do you see the cosine function? Can I now graph it? What questions can I answer? This is totally one of those things you're like, yeah, Miss Olivares, when you do it, made total sense. Could you do it on your own? We're going to practice to get you there. It would take some time. So we don't graph the parent function on these because it doesn't really help us. But I'm just going to highlight because that's my answer. What's my range?
-1 to 1.
Okay. All right. I have no questions. Did I go too fast? Okay. First period, I think I was flying by. They were like, whoa, you're going too fast. All right. Let's slide on over. Ready? Can I move?
Yeah.
All right. Oh, wait. One more thing. What did this graph do?
Horizontally compressed.
It horizontally compressed. But why did it compress if it's a 2? Because whenever you do anything inside the function like this, you're always going to do the opposite. Right? Do y'all agree that if it was minus c, we're going right?
Yeah.
And if it's plus c, we're going left? Isn't that the opposite of what you think? Same thing here. If this is a whole number, it's going to compress. And if it's a fraction, it'll expand. Okay? So, let's look at this one. This one's fun. This one is going to be expanding. Do you agree this is a b value?
Yes.
And because it's a b value, I need to do what? My new period. Find my NP. How do I find my NP?
2 pi over b.
2 pi over b, or 2 pi over 1/2. Now, I realized on your test when I was grading, there are quite a few of you that forgot how to divide by a fraction. What is my answer here?
4 pi.
Okay. Do y'all remember keep change? Some of y'all are like, I don't know. Do y'all remember keep, change, flip? I'm going to keep 2 pi the same. I'm going to change this to multiplication, and I'm going to flip my fraction to 2 over 1. And what is 2 pi times 2? 4 pi. My new period is 4 pi. So what does that mean I got to do on my x-axis? I'm going to do pi over 2. 1, 2, 3. Pi. 1, 2, 3. 3 pi over 2. 1, 2, 3. 2 pi. And then what's going to come next? Where are you getting 5 pi over 2?
Because that's 2 pi plus pi.
2 pi plus pi over 2. And then 1, 2, 3, what comes next? 3 pi. 1, 2, 3, what comes next? 7. Do y'all notice a trend with my over 2s? 1, 3, 5, 7. It's your odd numbers. 4 pi. Does that make sense? And then let's do my x-axis or y-axis. Okay. What function are we doing?
Sine.
And where does that start at?
0, 0.
Everybody plot 0, 0. And where does sine end at? 4 pi. Where does sine normally end at with 2 pi?
Oh, 2 pi 0.
So it's going to go 4 pi 0. So sine starts and ends at 0. Cosine starts and ends at 1. And then what happens in the middle of sine? There's another 0. Where am I going to put that at? 2 pi. Is everybody with me so far? What? How do we get the 0? So we know where it starts at. That's not going to change. Okay? We know my new period is 4 pi. So my regular parent function, do you agree the period's 2 pi? And it ends at 0? So the same thing's going to happen, but this time it's going to happen at my new period, which is 4 pi. Does that make sense? And then now to figure out everything else, you're just kind of doing the middle, right? In the middle right here, there's another 0. So what's in the middle of 0 and 4 pi? 2 pi. That's how I determine that one. Now, what does sine normally do after 0, 0 up front?
Goes up.
Up to 1. Where is this going to go up to 1?
Pi over 2.
Why? Ooh.
No pi. Pi.
Why? Because it's in the middle of these two zeros. And then where is it going to go to down to negative 1? 3 pi. And then be careful, because it's so stretched, it can get a little mountainy. Make sure that you are still curvilicious. Wow, that was a pretty good curve for me. What questions can I answer about what I did, why I did it, anything like that? And it goes still, why is it still negative 1, 1? We're not doing anything vertical. We're just dealing with horizontal. My range isn't changing from the parent function.
Do any other periods last when you say like curvilicious and stuff?
Yes. I think I was singing. Y'all know where I got curvilicious from, right?
No.
Fergalicious?
Nope.
Y'all know who Fergie is?
No.
You know the song? Curvilicious. Yeah, I just made it up. No, Fergalicious?
I think I'm too young this.
You're probably right. Yeah. Sorry, I'm a millennial. My bad. Okay. God, what did somebody ask me yesterday? I think I was offended, but I can't remember what she asked me.
Offended?
I was. We'll talk about it later when I'm not on camera. Okay, now, I'm about to blow up everything I taught you.
No.
Not everything, half of it.
Why is
Do you agree this is a b value right here?
Yes.
And it's pi.
Yes.
Okay. This I'm not blowing up. If I have a b value, what do I need to do? I need a new period. So it's still going to be 2 pi over b. What is 2 pi over pi? 2. This is a special case. Why? Because where is 2 on your x-axis right here? It's not 2 pi. It's just the number 2. Where is the number 2 on your x-axis? Like, I don't know. Not on the y-axis, on the x-axis. It is on the y-axis. But do you know where 2 is over here? I'm going to guess it's somewhere between 3.14 divided by 2 and 3.14. But do I know where? No. I don't want you to guess where. What I want you to do is say, let's just change our x-axis. Let's graph our x-axis like we've been doing our y-axis. So, if you have a new period that has no pi's, then your x and y-axis will match. What do I mean by that? If you have a new period that has no pi in it, your x and y-axis will match.
Oh, so the x is like 1, 2 squared.
So the x-axis is going to go skip 1, 1. Skip 1, 2. And I'm done. And still do your y-axis. Does that make sense?
Yeah.
Okay, because I don't want to sit there and try to figure out where 2 is. I'm just going to make my axis go with this method. Okay. What is the function? Cosine. Where does cosine start at? 1. Everybody put a point on 1. Do we all agree cosine starts at 1?
I drew on the wrong one.
Where does cosine end at?
2.
My new period is 2, so it needs to end at 2, but where does it need to end at? 2. Everybody put that. Do y'all agree that's the starting and ending? Where am I going to go down to negative 1? At 1. It's the middle. I'm going to go down to negative 1. And where are my zeros going to be at? Which are 0.5 or 1/2 and 1.5. And then you graph it and make sure there's no straight lines there. Was that weird?
A little bit.
Did it make sense though?
Yes. You should give us a test on that.
I should give you a test on this. I am.
What kind of question? Like immediately.
Immediately. No, you don't want a test on this immediately.
Give us a test.
Your test is 1 week from yesterday. I lied to you. 2 weeks from yesterday.
1 week from yesterday. That would have been crazy.
That would have been crazy. No, we haven't even learned all the reciprocals.
Are you serious?
Okay. My throat is hurting. Do you think you're ready to try on your own, or you want to do one more together?
Yes.
On your own.
Yes.
Are you sure?
Yes.
Okay, if you're sure, do it. If you're not sure, I'm going to silently do this so you can watch. What does it equal? 6. My new period is 6. Did y'all get that?
Yes.
Okay. So, is there a pi in that?
No.
So what do I do?
Match it on the y-axis.
I don't know how to be quiet. Can y'all tell? But y'all were looking at me like you didn't want me to be quiet, so. Look up to make sure your scaling matches my scaling. Where does sine start at?
0, 0.
Where should sine end at? 6 what? 6 0. Oh, y'all did not say that. Where is my other 0?
3.
I saw a reel yesterday, because I'm not on TikTok, because I refuse, that said, because I'm old, that's why, that was like, I'm just going to make a worksheet and all the answers are going to be 6.7, 67, 6.7, 6,007. And yeah, and then just trip out all the kids. And I was like, that would take some time, but Okay, where's 1 going to be?
1.5.
Why? Because it's in the middle. And if you're not sure, count the squares. 1, 2, 3, 4, 5, 6 squares. What would be the middle? 1, 2, 3. And then where would the other negative 1 be? 4.5. What is my range?
Negative 1 to 1.
Again, we're not doing anything vertical, so they're all negative 1 to 1. Are we feeling okay about this?
Yes.
Y'all are making me feel like a lot better teacher than I did in first.
Yes, I need a brain break.
You need a brain break.
So we don't do anything.
What time is it? The brain break. We can talk about...
Guess the logo.
No, not right now. I don't have that prepared.
Oh, are you still recording?
Yeah, I'm still recording.
Does this mean I'm going on the video?
You are definitely on the video.
Yes.
Alright, can I change it? Because the next 2 we're going to go a little bit quicker. I think y'all will do better on these. Or not better, but just you'll get these quick. Alright, what is C going to do for me?
Shift left or right.
Shift left or right. The biggest issue with shifting left or right is...
It does the opposite.
It does the opposite. So what is this first one going to do here? Left or right?
Left.
Left or right?
Left.
Are you sure?
Left.
Yeah. It's going to go left pi over 2. But be careful. How many squares is that?
2. Oh, 3.
You need to know that is 3 squares. So when we're only shifting left and right, I am going to draw the parent function real quick. Like we did yesterday. All right. Oh, I see y'all still. Are y'all drawing the parent function?
I'm just marking my
X and Y axis. Lightly outline the parent function.
Miss, I just made it perfect without the dots.
Good job.
It's delicious.
All right. What are you going to do with each point? Shake it to the left.
3 squares.
3 squares. 1, 2, 3. 1, 2, 3. What is the period here? Did I have a B value? No. There is no B value here. This right here is a C. So do I have a new period?
No.
No, what's my period going to be? It's just going to be 2 pi like it always is. What's the range here? -1 to 1. Now, I would count points off of this graph if you did this. Where would I find a reason to count points off?
If you didn't highlight it.
Nope.
You didn't label it.
I don't have a label on this point right here. What point is that?
Negative pi over 2.
-pi/2. Make sure that all of your points have a label. Would you like to do the next one on your own? Go. Do I have any questions about this one?
No, but can you go silently on the second one?
Yeah, we'll see. Bless you. Although I'm being silent, not really right now, but if you have a question, please ask me. That's the parent function. All right, look up. Did everybody get the one I am highlighting as their answer? Make sure for pi you're going 6 squares. And then again, why would I count points off? How do I know what is this right here after 2 pi? Remember the odd ones are over 2. So 1, 3, the next one would be. And then that's still going to give you points off.
3 pi.
You have to also label 3 pi. What questions can I answer? That is, yes, there's number 3 is what we're going to finish these last 2 tomorrow on number 3. But you can get started on 1, 2, and 4 of your homework if you wanted. Yeah.
On graph paper?
On graph paper. It has to be on graph paper.